Let us first consider the movement of the left platform associated with velocity v1. The force exerted by the damper to resist the movement of the platform is Fb1, whereas the force exerted by the spring is Fk. Hence, for the platform, we can write F minus B1, Fb1 minus Fk is equals to 0. We next consider the platform on the right, which has a mass of m. The forces acting on this second platform is Fk due to the spring and Fb2 due to the second damper. Hence, we can write the second equation of Fk minus Fb2 will be equals to 0. Let us next work on the analogies, having a table of the mechanical element, the mechanical flow, the electrical flow, and the electrical element. The mechanical elements are the force F, K, the spring, B1, the first damper, M, the mass, and B2, the second damper. In the case of the mechanical flow, V1 is associated with the force as well as the first damper B1. In the case of the spring, the mechanical flow is V1 minus V3, whereas for the mass of the second platform M, the flow is V3, and as well as for the second damper B2, the mechanical flow is V3. The next step of inputting the electrical flow is very straightforward. Finally, we complete the table by looking at the electrical element, where a voltage source is equivalent to a force, a capacitor is equivalent to a spring, a resistor is associated with a damper, and finally an inductor is associated with mass. We next try to create a sketch of the analogous electrical circuit. Let us first of all consider the elements which have the flow I1 alone. Clearly, we have a voltage source V and a resistor R1 that is associated with I1. Hence, the part of the circuit is shown as such. We next consider the elements associated with current I3. And we find that there is an inductor L and a second resistor R2. Hence, we can draw that part of the circuit as such: current I3 flowing past L and R2. Finally, we consider the elements associated with current I1 minus I3, and we find that there is a capacitor associated with it. Hence, our sketch would have an arm coming out from this node with a current I1 minus I3, which supports one capacitor. The circuit sketch allows us to construct the complete circuit, and it is given as shown. Notice that two meshes flow, I1 and I3. The use of two meshes corresponds to two equations that we have created earlier.